Hi everyone, welcome back. We're going to go ahead and finish 3.3 today. So 3.3, real zeros of polynomial functions. The essential question for today is, how can I reduce the number of possible zeros to test? The focus for today's lesson is Descartes' rule of signs, as well as upper and lower bounds. Now, yesterday we sent you through the rational zeros test where you had to test out a bunch of possible zeros in order to see which ones would actually help get you some factors. Problem is, when you have too many of them, it ends up being a very tedious process. Today we're going to go through two things that can help reduce the amount of steps you have to take. So the first focus is going to be on Descartes' rule of signs. And this is actually in your textbook, so I'm going to go ahead and put this up for you guys. So Descartes' rule of signs. Go ahead and copy, as usual, the highlighted section. In here, what we see is a huge polynomial, just like we've seen before, where we have real coefficients and that the final constant is not zero. The rule of signs basically tells us that for the number of positive real zeros is equal to the number of variations in the sign of f of x, or less than that number by an even integer. That definition is honestly very confusing, but go ahead and write that in, and I will explain that more thoroughly in the example. Second one is the number of negative real zeros of f is either equal to the number of variations in the sign of f negative x, or less than that number by an even integer. In other words, this little rule of ours is going to help tell us how many positive zeros we have and how many negative zeros we have based on how the signs change in the function. Okay, so again, it will make a lot more sense when we see it. Here, there's a variation in sign. Go ahead and read that, but I'm going to go ahead and switch over now. So the first example that I want to focus on is using this function where we have, let's see, f of x equals 2x cubed plus x squared minus 5x plus 2. What I'm looking for is a variation in signs. In other words, I want to see where they alternate from positive to negative or from negative to positive. It always helps me to rewrite it, so I'm going to go ahead and positive, positive, negative, positive. In our original function f of x, we actually have 1 and 2 variations, which means that I have 2 positive zeros, but like in Descartes' rule, it said it's either that number or an even number less. So if I were to take 2 away from this, I could also have 0 positive zeros. So this little rule helps us out a little bit, but at the same time it could be a bit restrictive or a little confusing depending on how many we actually get, because we could have some imaginary zeros. Now we're going to check if we have any negative zeros by substituting in negative x for each x value. So I'm going to have 2 negative x cubed plus negative x squared minus 5 negative x plus 2. This is going to come out as negative 2x cubed plus x squared plus 5x and plus 2. Here I only have one variation because all of these are positive except this one. So I have 1 negative 0. So using Descartes' rule of signs, I'll be able to determine how many positive zeros I get and how many negative zeros. From there, I'm just going to go ahead and use the rational zeros test. P being the factors of my constant, and Q being the factors of my my leading coefficient, plus or minus 1, plus or minus 2. So my P over Q, the possible zeros include plus or minus 1, plus or minus 2, plus or minus 1/2. Okay, so I want to go ahead and test out for my negatives. It's actually really nice if you only have one positive or negative zero, because we know for sure that there will be one. With this one, we end up with 2 or that possibility of none at all. So I'm always going to go with the 1. 1, 0, because it simplifies things a lot for us. Now with this one, it is the luck of the draw. I do have to choose either -1, -2, or -1/2 in order to test for this. I guess I'm going to go ahead and choose -2. So let's go ahead and do our synthetic division. 2, 1, -5, and 2. Drop the 2, -4, -3, +6, -1, and actually, hold on, it should be +1, -2, 0. Nice. So it does work. -2 is our one and only -0. So let's make a note of that. -2 is our -0. And because I only have one -0, this is the only one. So my factor is going to be x plus 2. And everything else that's remaining, it's 2x squared minus 3x plus 1. At this point, I know that I'm going to have either 2 positive zeros or 0 positive zeros. This one I don't need to do synthetic with, though, so I actually can just factor this. X plus 2, 2x into x. Pretty sure it's -1, -1. Okay, so these are my factored out terms. And by doing that, I knew that I didn't have to test out for any more negative zeros. Right? So that's where our Descartes rule of signs can help us out. And in addition to Descartes' rule of signs, we're going to be testing upper and lower bounds, which helps us to limit how many numbers we have to choose from even more. Okay, so I'm going to go ahead and start it down here, upper and lower bounds. All right, and we do have a little more from the textbook to copy, so I'm going to go ahead and push this up. And while we get ready for that, let's go ahead and copy this section. So again, once again, all the highlighted stuff. More importantly, though, right here, it says a real number C is an upper bound for the real zeros of F when no zeros are greater than C. In other words, if one of our X values is an upper bound, that means all of our zeros actually have to be less than that number. So an upper bound is kind of like that wall blocking you off from any higher number. You want to choose lower numbers. On the other hand, we have lower bounds. So if we have a number that's all the way over here on this side, and it's saying that, hey, you have to stop there too, which means that we are basically going to choose some numbers between my upper and my lower bound. To find the upper and lower bound, it's not that easy, but it does require a little work, and it will help us out as long as we test out the correct values. Okay, so if C is greater than 0 and each number in the last row is either positive or 0, then C is an upper bound for the real zeros of F. Okay, if C is less than 0 and the numbers in the last row are alternately positive and negative, in other words, positive, negative, then C is a lower bound. Okay, we're going to see a couple examples of that with our next one. All right. So for this one, I'm going to go ahead and work on an awfully ugly polynomial, x4 minus 4x cubed minus 15x squared plus 58x minus 40. Yes, that is a minus 40, which means the factors of our constant are going to be plentiful. Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 8, plus or minus 10, plus or minus 20, plus or minus 40. Okay. Likely for Q, we just have plus or minus 1. So for PQ, P over Q, I mean, all of the possible zeros include every single one of these numbers, so I'm just going to say arrow all of these. And now imagine if I had actually forced you to test out every single one. That would be insane. So we're going to go ahead and use Descartes' rule of signs as well as the upper and lower bounds. So I'm going to go ahead and flip the page so that I have plenty of room for this. I'm going to remind myself that the original function is f of x equals x to the 4th minus 4x cubed minus 15x squared plus 58x minus 40. So in our original f of x, we have positive, negative, negative, positive, negative. That's 1, 2, and 3. So we have 3 positive roots. But again, it's also an even number less roots, or 1 positive. Okay. With f of negative x, I'm going to go ahead and skip a step. But I know that with even ones, it's going to come out the same number. So, hang on real quick. So with f of negative x, we're going to get a positive. With this one, we'll get the opposite, positive, negative, negative, negative. Here, I only have 1 negative root. Okay? So with 1 negative root, I know for sure there will be 1 negative root, and I got to find that one. With the other one, it's either 3 positive roots or 1 positive, so we're going to have to test out quite a bit of numbers. Okay, so let's go ahead and see first with a factor that's greater than 0. So we have a huge list to choose from, and I'm going to go ahead and start off with 8. So I have 1, negative 4, negative 15, 58, and negative 40. I drop the 1, get 8, 4, 32. This is going to look awfully ugly. 136, 194, 1552, and 1512. Obviously, this is not going to be a factor. That is not a remainder of 0. But we notice that all of these numbers after doing synthetic division are positive, so all positive. Which means that 8 is an upper bound. Meaning our positive, or actually our zeros, have to be less than 8. Because 8 is too high and it ends up with all of these positive values. We have to go lower than that. So, based on all of my possible zeros, I think the next one I would want to go for would be 5. So let's go ahead and test that out. 5. Let's do 1, negative 4, negative 15, 58, negative 40. Okay, drop that. I get 1, 5, 1, 5, negative 10. That would be negative 50. That would be 8, 40, and 0. Thankfully, 5 works. So 5 is going to be one of our zeros. And now, since I already have 1 positive, I'm just going to go ahead and check with my negatives now, just so I can show you guys the lower bound as well. So with c less than 0, I want to go ahead and test out, let's go with negative 5, just because I used the positive one. So with negative 5, I'm going to continue, 1, 1, negative 10, 8. So 1, negative 5, negative 4, 20, 10, and definitely not going to work, so negative 42. Okay, so this one doesn't work, but I noticed that this is alternating, positive, negative. So that means negative 5 is a lower bound, meaning that I do have to go higher than that for my negative values. So let's go ahead and try negative 2 then. Actually, negative 4. So 1, 1, negative 10, 8. That will come out as 1, negative 4, negative 3. Let's hope this works. 12, 2, negative 8, 0. Yes, it does. So we have x minus 5, x plus 4, x squared minus 3x plus 2. Finish this off, x minus 5, x plus 4, x minus 2, and x minus 1. Here's our 3 positives, and here's our negative, just as we predicted using our upper and lower bound and Descartes' rules. All right, that's it. Go ahead, move on to Google Forms. See you later.